So today we're going to talk about how to add and subtract rational numbers, i.e. how do we add fractions, especially when the denominator is not the same. In yesterday's lesson, we talked about how to add them if they were the same. So for example, we talked about this and the idea that we can add those fractions by just adding the top and then keeping the denominator same. These ones we can't. So we need to get a common denominator. And we do that by making equivalent fractions. Okay, so the question is, how do we do this? So we have to look at these two fractions and say to ourselves, okay, what's common with these? All right, so what do we have to multiply them to get a common denominator? Here, we might look at it and say, hey, we only have to multiply one fraction. So I can look at, right, so if I'm looking at 3/4, all right, I can look at 3/4 and I can multiply the top and bottom by 2. And then the denominator is the same. So my common denominator would be 8. Because the other fraction is 5/8, we can get that together. So we're looking at what's the common multiple that we can get. So if I'm looking at 3 and 4, I may have to multiply by 4 here, and I may have to multiply this one by 3 so that the denominators are the same. All right, so here I had to multiply these ones by 4 to make it 12, and I had to multiply these ones by 3 to make the bottom 12. Okay. All right. Same thing here. I may have to multiply this one by 11, and I might have to multiply this one by 2 to get them to 22. All right, and then we can put them together. All right, and at any time as you're watching this, you can push pause to write down your thinking, but the goal here is to make the denominators the same. All right, so go ahead, push pause, all right, try to make the common denominator for the last two, and then come back and check your thinking. So we're back. What did you decide to multiply these two fractions by to get a common denominator? If he said that you multiply these ones by 4 and these ones by 5, you're correct. All right. Here, this is hard, right? I may have to think about maybe multiplying all 3 of those together, okay? But I think the common denominator could be 24 because 24 divides by 8, 24 divided by 3, 24 divided by 2, they all work. So I have to think about what I would have to multiply these ones by to get those answers. All right? So this is the major thinking that we're going to do for today's learning. Okay? The next thing we're going to talk about are these 3 equivalent fractions. And they are equivalent fractions. The idea here is if it's in the numerator, if the negative is in the numerator, or it's in the denominator, or it's the whole fraction, right? These are all the same. These are all the same. But what about this one? Well, if I think about this, if I have -1 divided by -2, if I divide that out, that actually becomes a positive, right? Because if I take 2 negatives and I multiply, that's a positive. And if I take a negative divided by a negative, that is also a positive. We did this one a little bit different. We did this on the last lesson. All right, the idea there, change a mixed number to improper fraction. What this is saying is I have 3 groups of 5. So that means there's 15 fifths plus another 4 fifths. I could say that's 19 over 5. Okay. Here I have negative 2 groups and 30 and 3/4. That just means the whole fraction is negative. So whatever the result we get is still going to be a negative number. So here I have 2 groups of 4, which is 8, plus another 3 groups of 4. That's just going to be 11 over 4. And that whole fraction is negative. All right, so that just means this is the entire fraction is negative. All right. All right. Same thing here. I have 5 groups of 3. That's 15 thirds plus another 2 thirds. Okay, I got negative 17 thirds. So you're going to be asking, why are we focusing on these? All right, why are we changing from a mixed number to improper fraction? Is because the adding becomes easier and the subtraction becomes easier when they're improper fractions. They're easier to understand. All right? So this is kind of the major task here. All right? So when adding or subtracting rational fractions, move this up a little bit. Okay. We need to get a common denominator first. So if it's not a common denominator, okay, we have to do this. So if we look at this, our common denominator is going to be 8. You ask yourselves, okay, how do I do that? All right, I multiply the top and bottom by the same number. And then I can just add the tops together. All right, 6 plus 3 is 8. Same thing here. If I'm looking at this, I may have to multiply each fraction by the other denominator. That works. So my common denominator is 15. All right, 4 times 3, that gets me my 12. 1 times 5, that gets me my 5. And then I can think of it like this. So that's 7/15. If I look at the next one, I might want to change this to an improper fraction. So if I change that to an improper fraction, it's like saying two groups of 4, which is 8, and then plus the 3, so that ends 11. So this would be 11 over 4 plus 2 over 3. And then I can get a common denominator. All right, so here I multiply this one by 3 and this one by 4. All right. So we get 33 over 12 plus 8 over 12, and then I can put those together. So 33 plus 8, I could do that on my calculator, right? I can think about that. Okay. And as you are listening to this and as you are doing this, if you need to push pause at any time, that is perfectly fine. Okay. Here's the next question. All right. I changed this to an improper fraction. Okay. So what I want you to do is push pause and tell me what fraction you created from that improper fraction. Go ahead and push pause and see how it goes. So if you said negative 13 over 5, you're right, because we needed two groups of 5 and then added that 3, and that gets me my 13 on the top. All right? Then I need a common denominator. All right. So here I might multiply this one by 4, multiply this one by 5, and make sure you keep the negative going through. So on my calculator, that would be negative 52 over 5 plus, nope, sorry, over 20. Okay. And then I'm thinking about my integer operations. I'm thinking that combining to get that. All right, so I could go to my calculator and actually type in, right? I would go type in, right, negative 52 plus 35, right? So I could think of it like that as negative 17 over 20. All right, so a lot of little things that are happening there. All right, so you want to think about these as either proper or improper fractions. Okay. So if I rewrite that, one group of 5 is 5, plus 1 is 6. Okay, 3/4, that's a proper fraction, so we either want that as proper or improper, right? Two groups of 2 is 4, plus 1 is 5. Okay. And then I need a common denominator. So this is my thinking necessary moving forward. Oh, sorry, my fault. This should have been a 4. Okay. So we might have to look at this. What's a number that's divisible by 5, 4, and 2? Well, if I did 5 times 4, that's 20. Is 20 divisible by 2? Yep. So I have 20, 20, and 20. All right. And then I got to think about, what do I have to multiply 5 by to get to 20? I'm going to have to multiply by 4. What am I going to have to multiply 4 by to get to 20? 5. What do I have to multiply 2 to get to 20? 10. All right, so 6 times 4 is 24. 3 times 5 is 15. 5 times 10 is 50. And I can just think about these as a bunch of integer operations. So I can think about 24, 15, and 50 as just typing in 24 plus 15 minus 50. So I can think of it exactly like that. And that's going to be my number in the numerator. Okay, so step 1, improper fractions. Step 2, find a common denominator. All right. All right, and then add or subtract. All right, so I'm going to push pause. All right, and what I want to do is I want you to try this last one, and then I will tell you, then you can check my thinking afterwards to see if it works. So a couple of things I did here. I made this an improper fraction, so I changed negative 1/7/8 into negative 15/8. One group of 8 is 8 plus 7 is 15. Two groups of 2 is 4 plus 1 is 5. I got a common denominator. All right, add it together. Okay. You may have done something a little bit different. Maybe you said your common denominator was 16. That is okay. So what would that look like? Well, if I had this, and we wanted to make this out of 16, okay, I could multiply this one by 2, this one by 8. It just means our numbers would have been a little bit bigger. Okay? But if I still do that, that becomes negative 10, no, positive 10 over 16. So my question to you is this: are those equivalent? Yeah, I just have to put this in lowest terms. All right, so I might have to divide the top and bottom by 2 to get that answer. So you're thinking about this if you make a common denominator that wasn't the lowest common denominator, and that is perfectly fine. Okay? So give this a try, give the practice a try. We're working on, can we make an improper fraction? Can we add or subtract fractions? All right. Maybe I have to get a common denominator. Okay. And then there's a word problem at the bottom. All right. All right. To give that a go.